learners, welcome back to this video. Today we are going to proceed with the second lesson on the theory of quadratic equations. So let's get started with the video. Okay, so we are going to get the lesson objectives for this particular lesson. So at the end of this lesson, the learner should be able to first solve quadratic equations by the method of factorization. That is the second case when a is different from 0 and 1. Second is solve quadratic equations by the method of completing the squares. And thirdly, state and apply the quadratic formula to solve quadratic equations. The last is know the nature of roots of a quadratic equation. So these are the respective cases which we are going to see today. And also, just down on the video description is the link to the first part of the theory of quadratics, where we saw an introduction to quadratic equations and also the case 1 of the method of factorization, that is when a is equal to 1. Okay, so let's proceed. Let's get started with the video. So we have to solve the quadratic equations by the method of factorization. And so in this video we are going to focus on the case when a is not equal to 0 and 1, that the coefficient of x squared is not equal to 0 and 1. So in this case the quadratic equation is of the form ax squared plus bx plus c equal to 0. And to solve this problem we shall proceed as follows. So you get the first. We are going to find two numbers, say lambda and mu, such that lambda plus mu will give me b and lambda times mu will give ac. Now to easily get these numbers, like in the first case, it's easier to write down the factors of ac. Okay. So if we replace this expression in a quadratic equation, we get the following. So if we replace b by lambda plus mu in our equation ax squared plus bx plus c, we get that b is lambda plus mu as seen on the screen, and c, making c the subject in equation 2, gives c is equal to lambda mu divided by a. And that's what we observe here, equal to 0. And so simplifying or expanding the expression, we get ax squared plus lambda x plus mu x plus mu on lambda mu on a equal to 0, where this lambda x plus lambda mu have simply expanded this bracket in order to get this expression. Okay, so we now have that. From this other side of the expression ax squared plus lambda x, you see that x is common. So if x is common, I'll factor out the x and we have x into what will be left will be ax plus lambda, plus on the other side of the expression, this expression, we have mu, which is common, and I have get mu outside into x plus lambda on a equal to 0. And so if I take the LCM inside this expression, what I get is x into ax plus lambda plus mu on a times ax plus lambda. Now these two terms, ax plus lambda and ax plus lambda, are similar, so I can factor it out. So we can begin also by multiplying all through by a. So if we multiply all through by a in order to eliminate this a from the denominator, we get that ax into ax plus lambda plus mu into ax plus lambda equal to 0. And so factoring out ax plus lambda gives me ax plus lambda into ax plus mu equal to 0, from where we can get the respective expressions of either ax plus lambda equal to 0 or ax plus mu equal to 0. So we get the possible values of x to be either our x is negative lambda on a or x is equal to negative mu on a. So let's do some activities in order to enhance our understanding. Okay, so let's get an example. So we are going to take the first example. Let's see, first we are going to solve the equation 2x squared plus 7x minus 4 equal to 0, and secondly we are going to solve the equation 5x squared plus 12x plus 4 equal to 0. Then we are going to see some other cases. Let's say the third, that will be x squared minus say 49 equals 0, and lastly we have x squared is equal to 154. Okay, so let's get started with the problem. Okay, so the very first question, we have our quadratic equation 2x squared plus 7x minus 4 equal to 0, which we have to solve by the method of factorization. So as stated in the presentation, the coefficient of x squared a is not equal to 1, so we can write them down. A is equal to 2, b is 7, and c is equal to negative 4. And so we can get the conditions. So we are going to look for two numbers, say lambda and mu, such that lambda plus mu is equal to 7, and lambda mu should give me AC, which is 2 times negative 4, which is negative 8. And so what are the two numbers? So the easiest way to get this is to write down the factors of negative 8. So we write down the positive and negative factors. So we have 1, 2, 3, 1, 2, 4, 8, negative 1, negative 2, negative 4, negative 8. So those are the factors of negative 8. And so we can simplify, we can now try to get the possible value such that when we sum these two numbers, we have 7, and when we multiply, we have negative 8. So let's guess the numbers. So if we take 8 for example and negative 1, is it actually going to give us, let's verify. So if we take 8, if we take 8 times negative 1, what do we get? Negative 8. And if we take 8 plus negative 1, what do we get? 7. But does it actually satisfy our conditions? Yes. Two numbers that we multiply, we have negative 8, and when we add, we have negative 7. So we clearly see that it satisfies our conditions. So the two numbers will be 8 and negative 1. Okay, so I'm going to clean this part, and I will now see how to expand this. So what we get is the two numbers are 8 and negative 1. So what do? We simply replace it here. We have 2x squared plus, okay, plus, I'm going to replace 7x by 8 and negative 1, so it can simply be written as 8x minus x, then minus 4 is equal to 0. So what we get from here is, on this side, these two terms, we see that 2x is common on both sides, so factoring out 2x will be left with x plus 4 within. Then on this other side we have a negative sign which is common, and we have x plus 4 equal to 0. And so this means we have x plus 4 factor of 2x minus 1 equal to 0. So either x plus 4 is equal to 0, or 2x minus 1 is equal to 0. So this means either x is equal to negative 4, or x is equal to half, or x is equal to half. And so that's the possible solution to the very first equation. Now let's see the second. 5x squared plus 12x plus 4 equal to 0. 5x squared plus 12x plus 4 equal to 0. Now the coefficients are a is 5, b is 12, and c is 4. So we are looking for two numbers such that when we sum we have 12, and when we multiply we have 5 times 4, which is 20. So we start by writing down the factors of 20. We have 1, 2, 4, 5, 10, 20. So this goes with the negative. Okay, so we are looking for two numbers that if we multiply we get 12, and when we add we have 20. So what then can be these numbers? Okay, so we are going to proceed with these values which we observe on the screen. So let's check some possible combinations for us to get values that when we multiply we have 20, and when we add we have 12. Okay, so let's check. If we take 10 and 2, positive 10 and positive 2, so do we observe 10 plus 2 gives 12, 10 times 2 gives 20. So we clearly see that the values 10 and 2 satisfies those conditions. Okay, so it means to factorize the two numbers are simply 10 and 2. And so what we do is we replace. We have 5x squared plus, I will replace my 12 by 10x plus 2x plus 4 is equal to 0. So no matter the order of replacement, your result will be the same. You can still begin with 2x and 10x. So here we see that 5x is common. So this means we have 5x. What will be left will be x plus 2. Plus 2 is common. I have 2 into x plus 2 is equal to 0. So we get 5, x plus 2 is common. So we write it down, x plus 2 into 5x plus 2 is equal to 0. Now, with this, either x plus 2 is equal to 0 or 5x plus 2 is equal to 0. So the possible values of x is either x is equal to negative 2 or x is equal to negative 2 divided by 5. So that is the solution to those two equations. Now the third and the fourth examples are a particular case of factorization known as the difference of two squares. And for the difference of two squares, generally if we have two squares, a squared minus b squared is always given by a minus b, all that into a plus b. So that's the factorized form. So the third, for example, we have x squared minus 49 is equal to 0. 49 is a square number and this is the square of 7. So we have x squared minus 7 squared is equal to 0. So to solve this easily, we apply the difference of two squares. So it's going to be x minus 7 times x plus 7 equal to 0. So we get that either x minus 7 is equal to 0 or x plus 7 is equal to 0. So this means either x is equal to positive 7 or x is equal to negative 7. So that is the case of the difference of two squares. And the last was x squared is equal to 144. So for x squared is equal to 144. So the first thing I will do is I will bring this term on one side. So I will get x squared minus 144 is equal to 0. Now 144 is the square of 12. So it means I get x squared minus 12 squared is equal to 0. We apply the same case, x plus 12 times x minus 12 is equal to 0. That's the difference of two squares. So either x plus 12 is equal to 0, or x minus 12 is equal to 0. So this means either x is equal to negative 12 or x is equal to 12. So these are the possible examples we could see, and the last case, as I said, is the particular case known as the difference of two squares. Okay, so with this, let's proceed with okay, so now we are done with the method of factorization, and we have seen some possible examples, and we have solved some possible examples. Now we are going to see the second method of solving a quadratic equation, which is known as the method of completing the square. Now, what actually is completing the square method all about? So completing the square method is one of the methods to find the roots of a given quadratic equation. In this method, we have to convert the given equation into a perfect square. So we saw in the first video that the perfect square is of the form x plus alpha, all of that squared. Okay, so we can also evaluate the roots of the equation by using the quadratic formula. So the quadratic formula is simply born from the method of completing the squares. So it is obtained from this method. Okay. So what are the steps involved in solving a quadratic equation by the method of completing the squares? Okay. So we are going to suppose that the equation is of the form ax squared plus bx plus c equal to 0. And we are going to have the following steps which are going to permit us to solve this equation using completing the square method. So the very first step is we have to write the equation in the form such that c is on the right hand side. The next is, if a is not equal to 1, we are going to divide the equation by a such that we are supposed to make the coefficient of x squared to be 1. So if the coefficient of x squared is different from 1, we make it to be 1. Next, we now add half the coefficient of the term in x. Half the coefficient of the term in x, that is b onto all of that squared. Rather, now we are going to add this half the square of the coefficient of x on both sides of the equation. That's b onto a, all of that squared. And then we factorize the left side of the equation. We factorize the left side of the equation as the square of the binomial term. Then we take now the square root on both sides, and we solve for the variable x. So let's observe this on the blackboard. Let's analyze this on the blackboard. Okay, so now we want to see the method of completing the squares visually. Now we have a quadratic equation ax squared plus bx plus c equal to 0, where we know that a should be different from 0. And so, to complete the squares of this equation, we saw that the very first thing to do is to make the coefficient of x squared to be 1. And we can send the constant term on one side of the equation. So this means we have ax squared, dividing also by a, we have x squared plus b on a, all of that x, plus c on a is equal to 0. So I will take this constant term on one side of my equation. I will bring it this way. So this means we have x squared plus b on a, x is equal to negative c divided by a. Now the next thing is we are going to have the coefficient of x. We are going to have the coefficient of x, square it and add on both sides. Now the coefficient of x here is clearly b divided by a. So halving it means we are dividing it by 2, so that's b onto a, then we square it and add on both sides. So what we get is we have x squared plus b divided by a x, then we have plus, we now add the term b on 2a, all of this squared is equal to negative c on a, then we add now the term plus b on 2a, all of that squared. So we see that basically we have not changed anything in this equation. All we have done is we have created a perfect square on the right hand side, and also if we decide to cancel them out, we see that if I bring this term this way, it will definitely cancel out with this other one. So what we get is this expression on the right hand side is actually a perfect square. And what is the perfect square? So if we are to factorize this, we have to look for two numbers that when we multiply, we have b on 2a, all of that squared, and when we add, we have b on a, and simply the numbers are b on 2a and b on 2a. When we sum these numbers, we get b on a, and when we multiply, we have b on 2a, all of that squared. And so this is a perfect square, x plus in the form x plus alpha, all of that squared. So this means the right hand side of this equation will become x plus b on 2a, all of that squared, is equal to negative c on a plus, expanding that, we have b squared divided by 4a squared. And so the next thing is, after we have it in this manner, we now have to make x the subject. So what do we observe? We have x plus b on 2a, all of this squared will be equal to, so let's take the LCM. So the LCM here is practically 4a squared. So 4a squared divided by a will give me 4a times c, that will be negative 4ac, plus 4a squared on 4a squared will give b squared. All of that will be divided by 4a squared. Okay, so let's write it down properly. So writing it down, I have negative 4ac plus b squared, all of this divided by 4a squared. So the next step is I will take the square root on both sides in order to eliminate the square. So I'll take the square root on both sides, and this will yield x plus b divided by 2a is equal to plus or minus the radical of b squared minus 4ac, all of this divided by 4a squared. Now we also have to know that the square root of a divided by b is equal to the square root of a divided by the square root of b, and so this gives x plus b on 2a will be equal to plus or minus the square root of b squared minus 4ac, all of this on 2a, since the square root of 4 is 2 and the square root of a squared is a. So I'm going to send b on 2a on this side of the equation. So I get x is equal to negative b on 2a plus or minus the radical of b squared minus 4ac, all of this divided by 2a. And so we get, since they have a common denominator, we finally get the value of x. So x will be equal to negative b plus plus or minus the square root of b squared minus 4ac, all of this into a. Okay, so that is actually the solution which we get after solving an equation by the method of completing the squares. And so this equation is known as the quadratic formula. And also at this step, in order for us to take the square root, we have to ensure that b squared minus 4ac is greater than or equal to 0, since the square root of negative numbers do not exist. Okay, so with this, let's get a practical example. So we can solve one of the examples we had above at the level of the method of factorization. So we have 2x squared plus 7x minus 4 equal to 0. So let's solve that quadratic equation by the method of completing the squares. Okay, so let's take an example. We are solving 2x squared plus 7x minus 4 is equal to 0. So the algorithm is, the very first thing we do is we make the coefficient of x squared 1, so that's we divide everywhere by 2. We divide all 2 by 2. So dividing all 2 by 2, we have x squared plus 7 on 2, x minus 4 on 2 is 2 equal to 0. Now we'll send the constant term on one side, so we have x squared plus 7 on 2x is equal to 2. The next thing we do is we have the coefficient of x, that's half of 7 on 2. Half of 7 on 2 is simply 7 on 4. Simply 7 on 4. So this means they will square it and add on both sides. So we have x squared plus 7 divided by 2x. I will add the term 7 on 4, all of that squared is equal to 2 minus 7 on 4, all of that, so 2 plus 7 on 4, all of that squared. And so we have just completed the square. So this is now a perfect square. So it becomes x plus 7 on 4, all of this squared. Because two numbers that will multiply, we have 7 on 4 all squared, and when we add, we have 7 on 2. So it's simply, the numbers will simply be 7 on 4 and 7 on 4. So 7 on 4 plus 7 on 4 will give 7 on 2, and 7 on 4 times 7 on 4 will give 7 on 4, all of that squared. Okay. So with that, we have x plus 7 on 4, all of that squared will be equal to, on the right hand side we have 2 plus 7 squared is 49 divided by 4 squared, which is 16. So we get x plus 7 on 4, all of this squared will be equal to, the LCM will be 16 times 2, which is 32, plus 49, all of this divided by 16. And so we get x plus 7 divided by 4, all of this squared will be equal to 32 plus 49. So it gives 81 divided by 16. So the next thing we do is we take the square root on both sides. So we take the square root on both sides. So we get x plus 7 divided by 4 will be equal to plus or minus the square root of 81 is 9 and the square root of 16 is 4. And so we now add we now send 7 of 4 this way, that we subtract it from both sides. So it means our x will be equal to negative 7 of 4 plus or minus 9 on 4. And so what we get from here is either x is equal to negative 7 on 4 plus 9 on 4, or x is equal to negative 7 on 4 minus 9 on 4. So negative 7 on 4 minus 9 on 4 means we have 2 on 4, which is the same as half, or we have x is equal to negative 16 on 4, which is equivalent to negative 4. So therefore the values of x is equal to half, or x is equal to negative 4. Okay, so that's the solution. Now if we verify that same solution when we're solving with the method of completing the squares, we'll realize that the answers are the same. And so it tells you that no matter the method which you use in solving a quadratic equation, your results should be the same. Okay. So actually, we have seen the method of completing the squares. So now we are going to see the quadratic formula and the nature of the roots of a quadratic equation. So if ax squared plus bx plus c equals to 0, then the roots of the equation are given by the quadratic formula, which states that x is equal to negative b plus or minus the square root of b squared minus 4ac, all of that on 2a, where a is not equal to 0. If a is equal to 0, that equation will be undefined. So we get this. So the quantity b squared minus 4ac is called the discriminant of a quadratic equation. So the value of the discriminant tells us the number of roots which an equation can have. So there are conditions imposed on this discriminant. So what are those conditions? The first is if b squared minus 4ac is greater than or equal to 0, then the equation is said to have real roots. When we talk of real roots, it means the roots can either be real and distinct or real and equal. So that is a condition for a quadratic equation to have real roots. B squared minus 4ac should be greater than or equal to 0. So the equal sign comes to intervene for the case where they can be equal, and the strict sign comes to tell us if they are distinct or not. So if, for example, we are asked to show that the roots of an equation are real, then we have to suppose either they are equal or they are distinct. So we use the condition b squared minus 4ac greater than or equal to 0. And so this point can further be separated into two cases. We have the first, when b squared minus 4ac is strictly positive, then it means that this equation has real and distinct roots, or in other words, real and different roots. So that is the condition when it is strictly positive. And so this will also depend so much on the nature of the equation given. And for example, you can be asked to find a range of values for a given function, for the existence of a given function, and the function might not necessarily be a polynomial. It can be a rational function where you have some points which cannot be defined on that particular for that particular function, and so you will not be required to include the points. So all these conditions, they definitely work, but we have to be very skeptical with the case in which we are working. So we cannot solve, for example, and we are looking for a point where we are looking for a range of values, for example, and let's say 7 is an excluded point. Let's just say I have a certain function f of x divided by a function, let's say x minus 7, and while looking for the set of values, I realize that 7 is one of my critical points, and we come and we include 7. No, so we have to be very careful when solving. We don't include 7 since 7 is not in the domain of definition of that function which you have. So we have to be very careful. Now the next is when b squared minus 4ac is equal to 0, then the equation is said to have real and equal roots. So if the equations, if a quadratic equation has real and equal roots, then it suffices for you to show that b squared minus 4ac is equal to 0. So if the discriminant is 0, all we have is this quantity b squared minus 4ac goes to 0, and when it goes to 0, all will be left is negative b on 2a. That will be the value of x. So that's all. So we have a unique solution, one root, one and only one root. And now the next condition is if b squared minus 4ac is strictly negative or strictly less than 0, then the equation is said to have complex roots. Okay, now let's see the nature of the roots of a quadratic equation. Now this is a quadratic expression, x is equal to negative b plus or minus the square root of b squared minus 4ac on 2a. So we can observe two roots. We have negative b with the case of plus the square root of b squared minus 4ac on 2a, and we have x is equal to negative b minus. So there are two roots involved, and so let's see the nature of the roots of that quadratic equation. Now if we let the roots of the equation ax squared plus bx plus c equal to 0 be c, alpha and beta, then we can call one of the solutions to be alpha, and alpha is equal to negative b plus the square root of b squared minus 4ac, all of that on 2a, and we call beta to be negative b minus the square root of b squared minus 4ac, all of that on 2a. And so the nature of our roots will be of the sort: if we take the sum of these two roots, we are going to have alpha plus beta is equal to negative b on a, and the product of the roots will be given by alpha beta is equal to c on a. Now let's get this on a board to actually see how it comes about. Okay, so we have the first root was alpha is equal to negative b plus the square root of b squared minus 4ac, all of this on 2a, and we have beta is equal to negative b minus the square root of b squared minus 4ac, all of this divided by 2a, and the condition is a should not be equal to 0 in both cases. Okay, now the sum of the roots means we are summing these two roots. So alpha plus beta will be equal to negative b plus the square root of b squared minus 4ac, all of this on 2a, plus negative b plus minus the square root of b squared minus 4ac, all of this on 2a. Now they have a common denominator. That will be negative b plus the square root of b squared minus 4ac minus b minus the square root of b squared minus 4ac. So all of this is on 2a. Now let's observe. So we see that this term and this term will be simplified. So we'll be left with negative b minus b, which is negative 2b, all over 2a, which gives negative b on a. And so the sum of roots alpha plus beta is equal to negative b divided by a. Next, the product of roots alpha and beta will be negative b plus the square root of b squared minus 4ac, all of this on 2a, multiplied by negative b minus the square root of b squared minus 4ac, all of this on 2a. And so expanding, we are going to realize that we have formed the difference of two squares. So expanding, we get b squared minus b times the radical of b squared minus 4ac will be plus b times the radical of b squared minus 4ac. Next, minus b times the radical of b squared minus 4ac. Then the radical times the radical will simply give minus b squared minus 4ac. All of this 2a times 2a gives 4a squared, and so we get alpha plus alpha beta. Alpha beta will be this term, and this term will simplify. So we have b squared minus b squared plus 4ac, all of this on 4a squared. So b squared and b squared cancels out. So we have 4ac divided by 4a squared. So this and this cancels. 4 and 4 cancels, and so we are left with c on a. So therefore, the product of what's alpha beta is equal to c on a. Now, we can be given the roots of this equation in order for us to solve, in order for us to get the particular, in order for us to get an equation. So if the roots are given, then we can actually get the equations, but that we are going to see in our next video. So with this, this brings us to the end of this video. So thanks very much for watching, and please do not forget to like, share and subscribe. So in our next video, we are going to proceed with the nature of roots of quadratic equations and how to write down a quadratic equation when given the roots of the quadratic equation. Stay tuned, stay blessed.